So let's start first with attribute closure. Attribute closure here, in attribute closure, first you have to understand what do we mean by attribute closure. So here if you given a relationship like this and some functional dependency is given, and let us say it is asked to find a closure. This is how we will denote a closure. So if you want to find a closure, that means how you are going to do this. Okay, so that is what we're going to understand from attribute closure. So if you are saying any s plus, any attribute plus, this means that it contains a set of attributes which is determined by x, the attributes which is determined by this. So if you see a, what are the attributes? First a, if you are given, whoever it is given, that a would be their asset. Then the other attributes which is determined by a, from a what you are getting b, so that b will be there, right? That b will be there. Now if you see, from b you can get c, so c also would be there. From c you can get d, so d would be there. And from d you can get e. So this would be the attribute closure of a. Similarly, let's consider the example of a d closure. That means if a d I have to find, then a would also come, d would also come. Now from a I can get what? B. And from B I can get what? C. And from C I can get D, which is already here. And from D I can get what? E. So this would be the attribute closure of here. Now let's consider the same example itself, B closure. B closure means, first if you want to find B closure, first we will write what? B itself. Then from B I can get what? C. So I will write here C. Now from C I can get what? D. So I will write D. From D I can get E. So B closure means B, C, D, E. Okay. Now let's consider C, D closure. C, D closure means, first we will write C, then we will write D. Now if you see C, from C you can get D, which is already there. And from D you can get E. So I can write E. Now there is nothing else. So this would be what? CD closure. So if you see here, A closure we get everything. So that means A closure is a super key. Now AD closure also we got A, B, C, D, E, everything. So AD closure can also be a super key. Now if you see B closure, if you consider B closure you can get, you didn't get A. So that means it is not a super key. Here also you didn't get A, you didn't get B. So that means this is also not a super key. So now I hope you have understood what do we mean by attribute closure. Now let us see how you can find a candidate key. Okay. Now in order to find candidate key, the trick is that first you write everything. That is, first you write A, B, C, D, E. And what would happen? Then find, like I am talking about the trick in which you can do this. Okay. A, B, C, D, E, everything you write here and find its closure. What will be the closure of this? A would be there, B would be there, C would be there, D would be there, E would be there. Nothing else, right? Because if A, B, C, D, E, individually we will take everything first. So that is itself. Now we know from A I can get B, right? From A I can get B. That means what I can do is that I can cut out this B and write A, C, D, E closure. Okay. So their closure would be what? A. From A I can get B. Then C is there. And from D I can get what? E. Fine. Their closure is also A, B, C, D, E. Now I know from D I can get E. That means what I can do is that I can remove E, because from D I can get E. So I don't need to write E again. So now I have A, C, D closure. Now their value would be what? From A, C, D we will write first. And I know from A I can get B. And from D I can get E. So this is also a super key. Now can I remove anything? No. That means this ACD can be a candidate key. That means ACD is candidate key. Now if ACD is candidate key, if I told you ACD is what? Candidate key. if ACD is candidate key, then I have to introduce to you a new word, that is prime attribute. Now, prime attribute means if ACD is a candidate key, then prime attributes are ACD. These are the prime attributes if ACD is a candidate key. Now, I'm not telling that it can only be one attribute can only be candidate key. There can be other attributes which can be candidate key. So that means ACD would not be only candidate key. So in order to find out if there is any other candidate key possible for this relationship with this functional dependency, how to find out that? So in order to do that, we will see the prime attribute ACD, and we will see if any of this prime attribute is found in the right hand side of our functional dependency. Here right hand side we have B and E. No A, no C, no D, nothing. So that means ACD is our only candidate key. So if any of this ACD, any of this is present in our right hand side of our functional dependency, then only we can say there would be another candidate key. But here there is only one there is no in the prime attributes ACD, none of them is present in the right hand side of our dependency. So that means only candidate key here is what? ACD. Now if you consider this relationship here, the functional dependency is A to B, B to C and C to A. Now here also, how do we find the candidate key? So first what we are going to do, everything closure we have to find. A, B, C, D, closure we have to find. So we get A, B, C. First individually we will write everything, right? So that is enough. Now from A I can get B, that means I can remove B. So A, C, D closure. So their closure if I find, I have A, I have from A I can get B, from then CD is already here, right? CD is already here. Now I know, now I can say if from C to A, now if you see here, there is one thing that is known as transitive rules. We haven't discussed the what I would say, we haven't discussed the properties, but right now you'd have to just understand from A to B and from B to C there is a relationship. Then I can say A to C also there would be existing. This is called as transitivity. So if A to C, that means together from this I can say A to C exists. So that means I can cut out C. I can get AD closure, which would also give me A, B, C, D itself. Now can I remove anything? No. So this would be a candidate key. AD is a candidate key. So my prime attributes here, if AD is candidate key, that means if AD is candidate key means, so I hope you have understood the property of transitivity we haven't discussed here. So that we will discuss the properties later. Right now you have understood this part. So that means if AD is my candidate key which I got right now, prime attribute would be what? Prime attribute is A and B. Now you have to see if any of them is present in the right side. If we see in here, A is present in the right side, which is from C. So I can replace A with C and D. So that means another candidate key would be CD. If you find A closure, we will get all of them. So another candidate key is CD. So my now prime attributes are, there is A, D and now C also came. Now we will see if C is present in the right hand side. Yes. So that in the place of C I can write what? BD. So another candidate key is BD. So my prime attributes become A, C, D, B. Now B is there in the right hand side. A, AD we have already written. So these are my candidate key. Understood? So not only one, by checking finding the prime attributes and seeing if any of them is present in the right hand side, then replace that with the one in which it is determined by that value. Okay. So this is how you find the candidate key. Now I have told you there are some properties that you have to discuss. These are the properties. That means if Y is a subset of X, then X can be Y can be determined by X. That is possible. This is called as reflexivity rule. Now augmentation rule is that if I have these properties are very important for us to learn. If I have a functional dependency which say X to Y, Then if I add z to this x, then I can also add y to z. This relationship, this functional dependency would also be valid then. This rule is known as augmentation. X to y, then I can write one more attribute to each of them, x, z, y, z. It is possible. Now transitivity means if I have relation x to y, this is what we have discussed earlier, and I have y to z, then x to z is also what? A valid FD. Now union means what? Two relationship which says x to y and also x is saying I'm going to z. So union means what? X to y z. This is the union. This is what union means. Now decomposition means what? If x is having functional dependency with yz, then I can decompose this. Like this is the opposite of union, x to y and x to z. Union said what? If I have x to y and x to z, I can write it as x, y, z. Now decomposition means what? If I have x to y, z, I can say it as x to y and x to z. Union and decomposition. So reflexivity, augmentation, transitivity, union, decomposition is done. Now pseudo transitivity means, this is normal transitivity. Pseudo transitivity means x to y and y to z is there, but in the front of y there is another attribute w. Then we usually will say if x to y is there and if y to z is there, I would say x to z would be a valid FD. So here in the place of y, I am writing another attribute w. So that means x to w can be an attribute to, can be a valid FD. This relationship. So that means we will eliminate y from here, and then we have xw in the left hand side, and right hand side we have z. So that means z right hand side, w and x together here, like this. This is pseudo transitivity. Now composition means if you have two different attributes, you can combine them. But combining their left hand side, sz, you can see combining the sz, and right hand side you can combine wy. See, this is composition. Thank you.